And the RC.
Okay, good morning. Probably too loud. Let me adjust this mic a little bit. Okay, before we get started, I just want to tell you I appreciate that the students show up in my office hour yesterday, and then we realized there was a particular network problem with homework assignment number 2, part 1. It was, I said yesterday, I never experienced this before. But then I realized that about a year ago, I had a similar experience. And what happened was a particular port. It's not every single network port, but just one particular port seems to lock up. So we cannot access to that. And the thing is that it will require a machine to reboot to actually reset that port. That's a mystery about operating system. Sometimes did this because the way we use the port. So one quick way to fix this is actually we change the port number. It's like if this number doesn't work, we change the port number. So right now I sent an announcement for homework assignment number 2, part 1. Now I change it to 95602. I mean, it was 95601. I actually changed to 95602 and it seems to work. So it's just one particular port number for some reason, system lock up, and yes. You get a connect fail. Let me actually check. 1 second. It could be because the current server seems to be, it's not based on JSON CPP. So it actually very sensitive to incorrect JSON string. I didn't handle the, so it might crash again. Let me check. No, it's there. 95602. Let me, you should use the right VPN. Let me actually check myself. So the server is still up here. Let me check. Um, 169.237.6.102. Port number is 95602. And I will just put some yeah, I hate to do this. Action. Let's see, 36B. 2. Let me actually bring up my homework assignment. I just keep forgetting I should save a copy about everything I type. Yes. I just need this part actually. This part should be give me enough. Let me check. By the way, for testing purpose, you're always welcome to use this fake ID I provide. SID. Okay, seems to me I got everything correct. What? I got the same thing? Let me actually change the port number again. So it could be a port number fake, it's got stuck after a while. The same reason. Okay, I changed to 95604. Let's see if this works. Yeah, I changed the port. Now the port is okay. I mean, I have to change the port again. So lock the second port. Okay, so I don't want to reset the machine because the machine is actually somewhere in the office. I cannot access. It's actually under the facility. So I just put my computer there. I cannot reset it. So right now, let's change to 95604. Seems to me, actually, after a while, you lock up the port. For this particular homeware, I don't know why. But for other homeware, it looks okay. Okay, let's go 95604. Let me try again. Yeah, so far it's still working. That's strange that the port number got eats up somehow. Okay. I probably need to watch this very carefully and make sure everybody got their VSID, and then we can actually move on. After homework 2, this problem should go away, because that was a particular way we handle port in homework 1 and homework 2. All right, I'm going back to here. And I go to the server. Cyrus. Why is my connection reset? About 1 second. I'm actually going to. Okay, so this is what I'm going to do today. I want to keep pushing on homework 3. This is your reference implementation. I gave it to you. I think I want to go. This is a much simpler version about what you're supposed to do. I mean, some of you probably haven't opened it. I know yesterday, a few of you already showed me successfully your homework 3 part 1 is done. In fact, homework part 1 is not that difficult. If you follow the instruction, don't try to compile it, but just install the pre-compiled version of the installation package, and then for your platform, and then it should be working. Okay, and if you're using CSIF already installed this. Okay, so just let you know that. So the software package that you will download online is this package, ecs36b f2021 homework. Oh, sorry, homework 3. The second link you need to get. So once you've done part 1, then you can actually download this. Let me just get it. Okay, so I want to make a test directory. And then I'm going to ls./. Okay, the file is there. So I'm going to do a tar zxvf, means extraction. The file. but it was in the parent directory. I put it there. Okay, so basically what you see is after you extract the file, you should see this directory called ecs36b homework 3. So I would just go to ecs33 homework B, and then I just simply type a make. You will see a lot of familiar software that you have there. Wait a minute, what happened? What? No, there is something wrong with this implementation. Did I? That's very strange. You know what? To save the time, I might have screwed up something. So let's go to my environment in Cyrus. That's the easiest one. C, make a test, cd test, extract from this should work. Okay. All right, I have this file. Okay, let's hopefully this one. The same problem. Yeah, that's very strange. What did I do wrong? Uh-huh. Say it again.
So in the top of the instruction, right, it says to add some compiler settings, dash I flag, and then we'll the instructions.
I thought.
I don't think it's either by default.
Okay, so maybe let me take a look. This is embarrassing. Sorry about that. Let me go for my homework 3 instruction. Is this homework 3? No, this was homework 3 for last year. This is homework 3 for this year. Where did I set that?
Yeah. For a bunch of environments, you might also add dash I.
No, this is where did I say that?
So it's below all the pseudo app.
Here?
No, below the pseudo app. The last one, it's a bunch of environments.
Okay, okay, I got it. Yeah. That makes sense. Yeah, I remember that. Now I remember after you say that. Thank you. Let me actually do a Emacs on the make file. And I'm going to change here. So the way to change it is actually putting here. Let's see if this will get rid of the problem. Okay, it seems to me that's working. Let me make a clean. So make clean doesn't work. Oh, make clean. Okay, so then that means this one probably I have the same problem. I will go here the C flag, the CC flag. I'm going to put. I should put probably in the minus G flag here. All right, thank you. Thank you for the tip. It's very interesting because it was for my MacBook. I never have to do this. It's only for Ubuntu. It seems to me now with some update that my Mac also need to do that. All right, good. So this is a software. So you download it, you add that minus capital I flag as I specify in my homework assignment number 3 specification. Remember this part is you have to add this, I highlighted here. So you should be able to get everything compiled. So now I want to show you what this code is doing. So remember for homework assignment number 3, you're supposed to implement 4 different functions. Operator equal, get distance, get VSID, and the other one. You have 4, but this program is actually only have a 1 function. So I show you how you can implement 1 function. And what you will learn is how this can be done in a JSON RPC CPP setting, and then you can extend it to do other. So let's take a look at the first JSON file that specifies that one particular function. So this is the JSON file that specifies RPC JSON file included in the reference implementation. As you can see that this has only 1 function call, and then that function call is not get distance, it's not get VSID. Is just call it that function called ecs36b underscore HW3. So that is the only function that you need to worry that. But by the way, this program you don't need to do anything. It's runnable. Let's actually try to run it. The way to run this program is I have now 2 directories. Wait a minute. Where I am? Okay, I'm here. Why you didn't give me another window in the same location? Forget it. Oh, you know what? I have been always in the CS in the Cyrus. That's why I never been to the. I got it wrong actually. I was the first time I have that trouble. I was already on Cyrus Ubuntu, so that's why it didn't. It actually. I was never running on Mac this morning. So, okay, I'm sorry. Now I see what's happened. Okay, so I'm here and also here. So I have 2 places. They're both over here. All right, so I'm going to do server HW3. The server was created. And it's actually calling a bunch of, let me first show you how the program should behave. And then we can actually look at the code a bit later. So over here, I just do HW3 client. You can see that after I make a call, it says successful. It's actually calculate something and then send it to the other side. Okay, and this is the client side. If you go to the server side, it's here. It's actually received that there is a get distance. Okay, so I actually call it ECF36, but inside the program, it probably say that call is get distance. But let's take a look at the code. But you can see that now with this program, without modification, maybe just that make file tweak you need to do, then you can have a client server program to run. If you can run, because those 2 programs are actually configured to run on the same machine, on your machine. So you don't need to worry about IP address at all. You own both the client and the server. If they can communicate, produce result looks like this, then you know, number 1, your JSON RPC environment is set up correctly. Just reconfirm it's set up correctly. And the second thing is that now you can have an implementation. You know it's working for homework assignment number 3 because it has a shadow object. And then you just learn from that, you can actually implement all 4 functions this way. So let's actually take a look at the code. Let's take a look at the client code first. Okay, let's take a look at the client code, which you already have it. Let's go to client.cpp. Let me make it a little bit bigger. You can see that the client code for this is extremely short, probably less than 10 lines of code. And that's the client code. So what it does is essentially it creates 2 flights. It creates 2 flights And it basically call a function that's called get distance. All right, it's just one piece of code and then has each just call the distance. And you can see that both of them is not the real object, it's shadow object. So Shadowfly F3, Shadowfly F2, and then the port number is, remember, localhost, and the port number is 8384, which will see the correspondence. So localhost means that it's on the same machine. Okay, I just pick a number 8384, you will see that on the server side. But let's look at the Shadowfly, where Shadowfly is defined. Shadowfly should be defined in transaction. Oh, sorry. Shadowfly is defined in Shadowfly. .h. Okay, so here we have Shadowfly. It was inherited from Fly, as we mentioned earlier. And you can see that inside Shadowfly, it has just a constructor with this 4 parameter that's required by the core object. And then it has one function called get distance implement. That's the only thing it does. So let's actually take a look at shadowfly.cpp. Okay, this is shadowfly.cpp. Nothing extraordinary, but this is the essentially the constructor. It's basically using the inheritance syntax to initiate the flight, column flight with this 4 parameter. Those 4 parameter allow me to access to where the object really is. Okay, here's a call distance function. This is called distance function, has only one function. Of course, this is the line, remember, that the other day we went through. This 3 line basically help you to configure the HTTP relationship with the other side. That's the machine, and then the C string. And this is the call. You basically say my client dot ecs36b homework 3, and then you put the first string is get distance. All right, but the call is actually called, the function is called ecs3b hw3. So we have to actually look at where that's coming from. So I just wanted to, oh, too much. Just want to compare the file we have that before. Remember when we declare the RPC JSON, the first one is the name, and the name, I actually name it ecs36b homework 3. That's the function name. So in terms of RPC, it only recognizes this is the function I'm going to implement on both sides. So that's how I actually using this generic name to actually represent any function. I can do that. And then with whatever the parameter and argument I have over there. So that name got translated into this function, my client, ecs36b homework 3. But how it get translated, we have to look at hw3 client.h, which is generated by the system. Okay, so this file is actually generated by the RPC JSON I just showed you. And it creates a class called hw3 capital C client, which was the parameter we actually gave in the makefile. If you remember, in the makefile, I actually have a line that create hw3 client.h. Inside here, I set hw3 client. That this is the parameter I have to give for JSON RPC stuff, which is the program that will generate all the code. Okay. And inside here, let me actually make one window because this code is generated. So the first part is just the first function is just the constructor. Okay, it's an empty constructor, but the function that's called ecs36b homework 3, the implementation is here. Let me actually just go down to show you the whole thing. And make the window a little bit bigger because this is also not a huge amount of code. Okay, so this portion is that function that's actually create. This portion is the function that's actually created for that particular function that we specify in RPC, JSON RPC. So you can see that it's a function call that the Shadowfly Cpp actually called this function. So we are actually transition our control from Shadowfly to this code. And what it does is just put all the parameter you provided into a JSON. That's the JSON style programming. Remember that this is the way that's very useful for you to easily construct a JSON. Instead of for you to just manually type it, you can write such program. In fact, you can even do that for your homework assignment number 2 or homework assignment number 1. If you just use this library to construct a JSON and send it to the other side. And after you shuffle all this value into your JSON, what you actually make a call is this one. This is the real call you're going to start talking to the server. So you call this call method. And what's the name of the method? As I specify, ecs36b HW3, and then with that P, which is that JSON you just provide. So essentially what you're doing here is that you know the name of the method, and then you know the parameter, which is being encoded as a JSON, a large JSON, and then you just send it over there. By the way, this is so commonly used in a lot of this kind of network programming. So whenever I want to send the data, think about that. You want to send the data. This data could be a check, could be a movie, could be a video or voice, whatever data you want to send. And with a lot of other parameter, the easiest way for you to encode it is encode it as a JSON. You can actually use JSON to contain any kind of information, binary file, whatever you want to do, and just send it over the other side. And the other side, when they receive the JSON, they will just use the same way to interpret the JSON to extract every piece of information that you would like to transmit from point A to point B. Okay, this is so simple. It's only have like 6 arguments, but it can go many more arguments. It can go very deep into the depths because each of them could go depths. Let me just give you an example. When I try to look at a JSON in real life, in about 2013 or 2012, I remember the size of the largest JSON I actually found on the internet. At that time, it's about 20 megabytes. So one JSON, 20 megabytes to transmit information, whatever you want to transmit. But then in 2016, there was a large JSON. At that time, the JSON got bigger because the internet application got more complicated and people try to use JSON to do a lot of things. Just one single JSON I found is 2 gigabytes. Just grows so much. So I will let you guess. What was that JSON that cost about 2 gigabytes? One single JSON. This is the JSON I show you here is probably less than 30 bytes. What kind of JSON do you think you have 2 gigabytes, one single JSON?
Maybe it's more about gaming or streaming.
No. It was the second debate of Trump and Clinton on Fox News. And people discuss. The people make comment as they debate. And the amount of comments and amount of reaction is that much, 2 gigabytes. This is in the I still have that JSON, by the way, if you want to play around that. So it's basically represent you can think about, there is about, I think there were about 60 million of reaction in one JSON. So everybody click a like, everybody click I hate, it will be recorded. in that thing. And then people make that particular JSON, if I remember correctly, 400,000 comments. As they're debating, there are 400,000 comments are being added. So every single comment added to that, it's a new element, make a JSON become pending, become bigger and bigger. So eventually that JSON becomes 20 gigabyte overnight. So that's the size. And by the way, that was 2016. I think in 2021 right now, you can actually probably found one single JSON over 10 gigabyte. And of course, I mean, you usually cannot extract a JSON with 2 gigabytes, especially with like a live application, like a social media system, because what they did is that they actually send a small portion of the JSON and send it to you for you to display. When you click, you want to see more, then they will actually put more stuff into a like an increment, supplement JSON and to you to actually to your application. So there is so much way you can represent information with this magnitude and with this complexity into that. Okay, so that's the call method, but the call message really is just the name of the method with a JSON, and then it's the responsibility of the server to interpret whatever P is. And then the RPC mechanism, all they're responsible is that make sure you have this name and you have a valid JSON, and then I will send it for you. And the server will take care of the rest from there, okay? So that's that. This is HW3 client CPP. So now everybody good before we shift to the server side? The client side is very simple. If you look at the amount of code, of course, there is a lot of library you need to include it, but the basic mechanism is just that single line. You make a call, and then you connect to the code that was generated by the JSON RPC stuff to do that. Okay, so let's now go to the server side. Okay, let's first take a look at HW3 server.h. This is the code generated on the other side. And this is the base of the code that we're going to look at. So again, this is using the same RPC JSON file we specified with only one function. And it has the first line is called HW3 server. And it's inherited from JSON RPC, abstract server, whatever, blah, blah, blah. And inside here, you can see that they have a constructor. The first part is a constructor. This part is a constructor. And it has an inline virtual function, which is essentially called the line below. And then they have a real function that's here. So this inline is essentially calling this. So this is really the virtual function. It's over here. If you see the virtual function, it's with ecs36b, that's the name of the function, and then with all the arguments. Because when the HW3 server, when they receive it, they will parse your JSON and put the value into the 6 ID as specified. I mean, let's just count how many parameters. 1, action, argument, 2, 3 class ID, 4 URL, 5th object ID, the final is owner vs ID. Where does that come from? It's come from this file again. Remember this file? We specify action, owner vs ID, host URL, class ID, object ID, and argument. Apparently, when the RPC stuff, they actually took this alphabetically. So if you look at the order of the other code that's generated, just be careful. This is the tweaks they did. They actually go alphabetic order, become action, argument, class ID, host URL, object ID, and VSI owners VSID. So this is the 6 match by 6, but they arrange the code generation that arranged not original order, but the order of the of the alphabetic order for the name of the attribute. Okay, hopefully you're okay with this. So now I'm going to actually tell you something which is should be part of the lecture. A lot of people doing C++ didn't know this exists. Have you seen this? I actually do this virtual blah 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 specify, but at the end I have a equal to 0. So essentially, when I declare a function, usually when you have two options, you just end it with a semicolon, or you end it with a pair of curly bracket, like the inline above, and I just give a specify. And over here, we just put a equal to 0. What does that mean? Anybody want to give a guess why I said it's equal to 0? Yeah. Yes, it's a syntax of virtual function. That's correct. But what is that semantics about that equal to 0 means? Yes, that's correct. That's called pure virtual function. That's the name, pure virtual function. You have seen this before, right? Okay, I'm sorry. I'm sorry about that. So it's called pure function. What does that mean is that when you look at the inheritance hierarchy, let me actually show you the slides. Now I can finally put my lovely slides back. I believe I put a 6 or 7, probably 7. So this is the idea of a virtual function. And you have a base class, you have a derived class. So you both actually declare an implementation of get distance. So if typically in virtual function, you have a one implementation that's actually associated with base class, one implementation associated with derived class, and it depending on the object when they create it, was this created as a derived class or is it created as a base class? I will decide which version of the virtual function I should call. This by the creation membership to decide which function to call. So what's a pure function? Pure function means the top, the base class, it doesn't have an implementation. So essentially, this is what we call pure virtual, means that it's not real at all. It's a pure one. So regardless, whoever inherit from the base class, you must implement a real virtual function. So it means that I don't have anything for you to use as a default. You have to go down to the created, the derived class to access that. So my equal to 0, one way you can think about this is, remember we talked about function pointer. So function pointer is a pointer to something. So I assign that to 0 means that it's like a null kind of situation. It's just one way to think about this. And then essentially saying that that function doesn't exist, don't try to call it, means that the compiler will check if you really implement a real function for every class derived from this class. Okay, that's called virtual function. That's called pure virtual function. That's a technical term. Okay. All right, so now you have a pure virtual function here. So that means, okay, we're going to look at the HW3 server.cpp to see the real implementation. So I'm going to keep these things here, and I'm going to compare the HW3 server.cpp. Okay, HW3 server.cpp, at the beginning, is just a bunch of include file. This is all, okay, here is star. see, I actually create a class called capital N, my homework 3 server. That's actually inherited from HW3 server as I show you here. Okay, I have, this is HW3 server. This is my HW3 server. And inside here, I only have a 2 function. One is the constructor, and one is the function that was a pure function, pure virtual function as a base class. And now this is no longer base because why? I don't have a equal 0 here. It's just semicolon. And the order and the name of the argument are matching exactly like this. So compiler is actually looking for this. If you don't have this, compiler will say that function is a pure virtual function. If you don't define it here, the compiler will give you syntax error. Okay, all right, so now we're here. No, I don't want to go this way. I want to go to CPP. Okay, so now I have this class. Know what I did is the first one is constructor. That's easy. I just basically do a dummy printout for that default constructor. But here is a function that's actually I'm going to implement. So this is the real business. When you submit from the Shadowfly about that method get distance, it's going to be encoded and decoded through the JSON RPC. And eventually all this parameter will be extracted, and then it will actually call this function here. So when it's called this function, now this part is an example about how you should implement this. But let me actually show you, go through very quickly. What I did is first I actually check if the class ID is a flight, whether the object ID is the object ID I actually support. I will show you what is the object ID 002, 003 in a moment. But I'm actually going to check if it's none of this work, then I basically assuming the response is going to be failed because I didn't find the object ID you try to reach from the remote side. Means that the shadow object tried to connect to the real object, but the real object doesn't exist unless your class ID and object ID match with this machine. Okay, so if you have that, this is just error message. But if actually you match the object ID, for example, 002, I will just call F2 get distance. So F2 is a real object. So SF2 on the other side decline, those are the shadow object. Now you can see that it really find the real object. Now it actually called the real get distance. And then it get the result D, and then it encoded the result to a JSON string. And then this part of the code, the below part of the code is just essentially construct a JSON. By the way, this piece of code is so standard, you will use it again and again to construct any JSON for you to pass both from the client side and the server side. And essentially this part is make sure your JSON is correct, and the encoded JSON is called result. Where's the result? Somewhere. str. Yeah, here's the result. This is a JSON you're going to return, and then the result is actually specified very early in the first line. It's called result. This is the JSON I'm actually keep constructing for me to put it in. So what I did is I took over here, I just construct a string, looks like a JSON. And what I did is I using that string to convert it to a real JSON object. And then at the end, I just return the result. Okay, so let me recap what I said earlier. When I receive a call, the remote is going to be contact the server side, which is this function matching the method name called ecs36b homework 3. That's one function. Inside this function, I check the class ID and object ID, whether this is something I can support it locally. If it doesn't, I construct a JSON string, which is say failed or something like that. If it's supported, then I would just call the real method because I know where the object is and then get the result. In either case, I'm going to encode it, a JSON string represent the result. I'm going to send it back to the client. And then at the end of the result, this part, I'm going to convert that string into a real JSON object and just return that JSON object to the JSON RPC. And the rest, it will handle that, okay? Any question? Okay, now I'm going to show you the main program because the main program gives a lot of other information. Okay, so you can see this is the main program in the server. This program, essentially, I took it from your homework assignment number 2. I took the main program from your homework assignment number 2 and just put it here. I mean, maybe a little bit twist here and there. So you can see that I have a GPS DD, I have 3 GPS locations, 3 IP address, which is a fake. I create 2 person 1 and person 2. And I create flight 1 and flight 2. Okay, sorry. This is flight 1, but I actually create this 2 because the difference between homework 1 and, sorry, homework 2 and homework 3, give me just 1 second, is that I separate the class transaction from transaction, and then I have a flight. So I have a flight 2, which is I declare 002. That's where the object ID coming from. And then I have flight 3, which is 0003. And this is what I did. I actually do a pointer. Now I start remind you about C pointer. I actually put the pointer, the address of this 2 objects into F2 and F3. So that's why you can see that on top of this, the function, it says F2 get distance. And this is F3 distance. This just show a way in C or C++ how I can transfer control of the object reference from one function to the other function. In other words, F2, F3 are global variable. It's an ugly way of doing programming, but just get to the easiest way for us to get something running. That's kind of the hack I did. Okay, so that's the F2 is actually being set up here, F2 and F3. And then after you set up the pointer, this part is just set up the server. Now you see the number, port number 8384. This is localhost, and I set the HTTP server's port to be 8384. So when the client contact, they say localhost colon 8384. That's how it match with this port number. So over here, I just set up the web server and then just say start listening. And after I call this line start listening, means I'm started listening any incoming HTTP request, which JSON RPC is using HTTP request as a mechanism to communicate between multiple programs. Okay, so that's give you a very quick idea about how you can implement one single function. Try to learn from this to do the best way to me. If you've never done this type of programming before, it might be good for you to use this as an example, understand it, and then extend it. Just make 4 different functions out of that. And then you will actually get your homework assignment number, homework assignment number 3, at least the first 80% done. And then I'm going to talk about how do you actually handle indirect, means that you have one object called the other object, yet that object doesn't have a real object. It actually needs to go through another shadow. That's the 3 server version. But once you've done, my recommendation, get the 2 server version running first, get the basic points. And then after that, to be honest with you, if you can do that, to extend to 3 server is relatively easier. All right. All right, I'll stop here. Sorry to run a little bit over time.